Today we're going to solve quadratic equations. So let's go quickly review what does it mean to solve a quadratic. So solutions to the quadratics are also known as the x-intercepts, the roots, or the zeros. So ultimately we're finding the place where this graph crosses the x-axis and when y is 0. So looking at this particular graph here, the roots or the solutions are going to be at 1, 0, and 5, 0. So when we talk about them as like the x-intercepts, we would list them out as ordered pairs, 1, 0, and 5, 0. But when we talk about them as solutions, we usually just write them and we would say x equals, and then we use a little set notation, and we'd say 1, comma 5. So we're talking about the solutions, all the x's, or x equals 1 and x equals 5. So what are all the possibilities of types of solutions that can be had by a quadratic? So quadratics can have one real solution, and that's going to happen when the vertex is on the x-axis. Then there's only going to be one solution. A quadratic can have two solutions when it crosses the x-axis in two places. A quadratic can have two imaginary solutions, or we would say no real solutions, when it doesn't cross the x-axis at all. And so there's two examples there, so you can see. And we're going to talk more about those as we move into something called the discriminant in another lesson. So we're going to start today with just part of solving quadratics, and we're going to look specifically at solving quadratics from by factoring and also by vertex form. So those are the two methods we're going to look at today. So we solve by factoring, we need to have the factors, and we've done this already by finding the roots. So what's happening here is you're taking each factor and making it equal to 0. So 5x minus 2 equals 0, and 6x plus 4 equals 0. And then you're solving each of these mini equations. So we go through the steps. Let's look at this first one. So we're going to go ahead and add 2 to both sides. So 5x equals 2, and then divide both sides by 5. And x equals 2/5. So that's one of the solutions. Then we can go ahead and do the same thing to the others. Set up the other equation, so minus 4. 6x equals negative 4. And then divide by 6. And reduce that fraction, so x equals negative 2/3. So there are the two solutions there, 2/5 and negative 2/3. And you may also recognize that if you were to undo your slide and divide and slide, from when we did factoring, if we just slid that 5 back, it becomes the denominator for the 2, and there's your 2/5. And then same thing here, slide the 6 back, and it becomes 4/6, and as we know, insiders lie. And then you just have to reduce it. So some of you may just use that method also. Okay, so that was nice because it's already factored for us. Let's look at number 2. Number 2 is not factored. So we need to go ahead and factor that equation first. So in order to do this, the first thing we want to do is make sure that the equation is equal to 0. So I need to add the 24 to the other side. So that becomes x squared minus 11x plus 24 equals 0. Now I can go ahead and factor this trinomial here. So what I'm doing in my head is finding the factors that multiply to 24 and add to negative 11, and go through my list of numbers, and I believe we have negative 8 and negative 3, 8, 9, 10, 11, perfect. So then my factors then are x minus 8 and x minus 3, and then we're going to show that equals 0. That's important to put on there. And then at this point, you can set them as equations, or do we just know that if we're finding the roots, then we're also finding the solutions? So in that case, x is going to equal positive 8, and x is going to equal positive 3. And there are the solutions. Okay, and let's try one more. So here I have a 5x on the right-hand side, so we need to go ahead and move that 5x to the other side, subtract it over. So I have 6x squared, and I'm going to go ahead and put these in order so it's descending order. So minus 5x minus 4 equals 0. So now this is a little bit harder trinomial to factor. So I need to go ahead and do my step where I multiply 6 times 4. So I need numbers that multiply to negative 24 and add to negative 5. So I have to think about what those factors are. And that's going to give me negative 8 and positive 3 this time, because they're going to multiply to negative 24 and add to negative 5. So I'm going to write this as x minus 8 times x plus 3. But I need to take the a value and bring it down. So we divide by 6. So I'm just finding the factors. I'm just factoring right now. And lastly, I need to simplify, divide. So x minus 4/3 and x plus 1/2. Now at this point, I need my equals 0. At this point, if we wanted to write the actual factors out, we would go ahead and slide those up. But when I see this, this is already set up for me to find those roots, which are the solutions right like this. So insiders lie, so the solutions then are x equals positive 4/3 and x equals negative 1/2. And those are the solutions. I don't have to do any more work. I don't have to go through all the solving steps I did up here when I already have it at that point. Okay, the second type of solving is from vertex form. So we're going to go ahead and we will give you the equation in vertex form, and really what you need to do is peel away the layers. And the goal is, just like when we worked with absolute value equations, the goal is just to get the x by itself. So the first thing I want to do is subtract the 12 on both sides. Okay, now I want to go ahead and divide by 3. I'm just peeling each set of layers away. And so I have x minus 1 squared equals negative 4. Now the next layer to peel away here is the square itself. So to undo the square, we need to actually take the square root of both sides. But when we do this, it's real important that we remember to always include a plus or minus sign. Plus or minus when taking the square root of both sides. Okay, you have to have a plus or minus sign in there. I didn't leave myself any room. It's going to be tucked right in there, the plus or minus sign. Let me rewrite that so you can see. So what this really means is I have just the x minus 1 equals plus or minus the square root of negative 4. Okay, that plus or minus has to be in there because we don't know if it was a positive or negative that started this problem. Now, we now know how to simplify the square root of negative 4. That's going to be just 2i. So x minus 1 equals plus or minus 2i. And then the last thing I'm going to do is add the 1. And positive 1 is a real number, so that cannot be combined with the 2i. It has to stay by itself. So my answer in the end is just x equals 1 plus or minus 2i. And it's kind of weird, but what we're really looking at here is one solution that's 1 plus 2i, and then the second solution is 1 minus 2i. And those are the two solutions that we have. And we can't do anything with that I because it's an imaginary number. Okay, let's try number 5. Same idea. And we're going to go ahead and peel the layers away. So this time we're going to add the 36. And we get 2 times x minus 3 squared equals 36. Then we're going to divide by 2. So we have the x minus 3 squared equals 18. Okay, then we're going to take the square root of both sides. When we take the square root of both sides, I have to include the plus or minus sign on the right-hand side to go in front of the radical. So that gives me x minus 3 equals plus or minus the square root of 18. But the square root of 18 can be reduced. It can be simplified. So you can go ahead and use whichever method you want. If you want to do a factor tree or if you want to do upside down division, go ahead and break down the 18. When you break that down, what you should get is 3 radical 2, the plus or minus sign on that. X minus 3 equals, and then we're going to go ahead then and add the 3 to both sides. Now again, we cannot combine the 3 with a 3 radical 2. They're not like terms. The radical 2 is most important there. It stays separate. So this just becomes x equals 3 plus or minus 3 radical 2. That plus 3 just slides right into the front of that plus or minus there. That's where it goes. Okay, so what does this really mean? It really means that I have 3 plus 3 radical 2, and I have 3 minus 3 radical 2. Both of those are the solutions to this quadratic. And if I were to put this equation in my calculator and look at the graph, these here I can actually get decimal answers. If I type into my calculator 3 plus 3 radical 2, 3 plus 3 radical 2 in my calculator, I end up with a decimal approximation, just so you can see what's happening. This is approximately 7.24. And then if I type the second one in, 3 minus 3 times the square root of 2. On this one, I get negative, so this is negative 1.24. So those are the decimal approximations. These are approximately those decimals. In example number 4, I cannot find decimals for these because of the imaginary, because these are complex numbers. Okay, be ready to show these notes to your teacher tomorrow.